This episode is sponsored by United Refrigeration and Westermeyer Industries, revolutionizing your HVACR experience. Visit URI.com for all your HVACR needs, offering real-time inventory, personalized pricing, and a nearby stock feature. Access quick pick replacement parts and branch details effortlessly. With 350 plus fully stocked locations across North America, our knowledgeable staff are ready to assist with the solutions you need. Exclusive offer. Use code ARPOD on URI.com to get a $10 gift card when purchasing the Westermeyer oil float, part number W4300-38F. These high-performance floats are not just compatible with their own oil separators, but also available as a crossover model, conveniently stocked at United Refrigeration. That's code ARPOD to claim your $10 gift card. Visit URI.com now.
The Sporlan division of Parker Hannifin Corporation is sponsoring this podcast. Sporlan is the leading manufacturer of HVAC and R components. Using quality materials and craftsmanship, Sporlan maintains a commitment to innovation, manufacturing excellence, service, and support for its customers since 1934. The company is known for its catch-all filter dryers, thermostatic expansion valves, solenoid valves, pressure regulating valves, suction filters, electric valves, controllers, supermarket monitoring solutions, chemicals, smart service tools, Zoom Lock Max, press to connect, and Zoom Lock Push to connect refrigerant fittings. If folks want to learn more, what do they do?
You can go to sporlan.com.
I guess that's Jim and John for Sporlan signing off.
Good afternoon, everybody. Welcome to Advanced Refrigeration Podcast. Here are your hosts, Brett Wetzel and Kevin Compass. I was going to say I haven't talked to you for a while, but we just recorded a couple days ago. So what are you doing this week?
I am continuing piping this CO2 rack. Today we are piping the gas cooler and got done in about 2 minutes before a torrential rain pour started pouring down. So that was cool. So got that all piped up, and then I spent the rest of the day trying to figure out all this pump control stuff that has to get done at this job site. So like we're on this particular job, I have 11 VFD driven pumps, all doing different things. Some are controlling a geothermal water loop. Some are controlling chilled water loops. Some are controlling heating water loops. Some are controlling domestic heating water loops.
Jesus.
Yes, there is a lot going on here. And then some are controlling a chilled water mixing buffer tank. And all this has to get tied together and made to work in probably the most complex way possible. And all these pumps are controlled off of flow, BTU flow or differential pressure. So is what they're trying to maintain. They're trying to maintain a differential pressure switch set point and also a flow. So this particular store has flow meters on everything. So they have Omnicon flow meters, which I've never seen before, but they are pretty sweet. It's temp sensors built in. So it has 2 temp sensors, a supply and a return. Then it has an actual flow meter where it's measuring the actual volume and flow of what the pump is putting out.
So let me stop for a second. So you have to do differential as well as maintaining the flow. So I'm assuming that means that you have to have a certain amount of glycol in there, because otherwise one's going to affect the other. Yeah.
Correct. So I think we're going to run the pumps off of flow GPM. So it's going to be run off GPM because we're able to calculate GPM
based off of the differential and the flow.
Based off of the flow meters. They're actually calibrated to the size of the pipe and the glycol, and they're already all calibrated. So they're actually spitting out a GPM number on an analog signal.
Does the refrigeration schedule that you're dealing with actually tell you what amount of GPM needs to go through those things? Or
so we have the GPMs that the heat exchangers are sized for. So it's like a unknown to a sense because what was there and then what they re-engineered everything to. So we have that GPM. So we can control off of that GPM and that flow.
Gotcha.
So, and then we got to set everything up for lead lag. And some of the stuff is triple lead lag. So there's 3 pumps. So
really?
Yeah. The chill water side is like super complicated. And so is the geo side.
How's that going to work when it comes time to service it?
Interesting. It's going to be interesting. It is by far one of the most complicated CO2 racks that I have yet to start up.
I know a
and
guy
I've done a bunch of Carnot stuff, and this is way more complicated.
Really?
But there's just it is and it isn't. But there's just so much going on in this rack.
What control system?
E3.
Oh, thank God. And I only say that because if it was any other with microthermal, it would probably be okay to do. I've never done it. I'm guessing just because I know that they do the block logic, and you can do a crap ton with the block logic, but at least you can be controlling over the calculations for the flexible combiners, right?
Yeah. The only thing, the caveat to being microthermal would be like a lot of this stuff would already be canned, like the pump control.
Yeah,
it's already all canned.
Gotcha.
So they already have the application for the pump control for the glycol racks. They do. So you literally just take that and slap it in there. But the E3 having the ability to do the layouts is going to make this a lot better. So having the PNID in there, because following this thing, like you've seen the PNID, like there's a lot going on in there.
Did I?
Yeah, it was the one with the check valve that we had to add.
Oh, that's right. Oh, okay. I got a crappy picture. I was like, I thought you sent me something.
Yeah, no, there's just a lot going on. There's a lot of pump control going on. So today, I figured we'd talk some more about pump control on glycol and condenser loops and what's going on, because Ray's going to start doing a bunch of, or Ray Corp, however they say it, is going to start doing a bunch of stuff at Walmart. You guys are going to see a bunch more glycol skids coming out. There's a bunch of glycol skids all over the place. We do a lot of high-rise stuff, so we have mini glycol skids all over the place for condenser loops and stuff like that. So let's hit it.
Yeah, I'm gonna have Ray actually come on, so I don't give any horrible bad information, but I'm gonna go through what I know already on some of this stuff. So share. All right, let me just do entire screen. There we go. So there is the loop for this bad boy here. So you can see like everything here is basically labeled out, where the sensors are, where the hand valves is. So one of the weird things about this on the heat exchanger, which is this guy right here, they don't have any flow meters on here. They're actually doing a calculation between feet of head and the GPM calculated. And so they have a pretty little Corel. I think it's a Pico, one of the Pico controllers. It's comparable, almost like having like an RDM TDB controller. It's just a blank slate, so you program it however. But they're doing this off a calculation that they developed. They actually give you a spreadsheet. Let me just see if I have that. Nope, that's not it. All right, let me look for that while we're.
So, question here, Brad: are they running VFDs on those?
They are. They are.
God.
They are, and they're doing lead lag. So that's the other thing too. They're doing lead lag on this thing. So you're. That's you.
Yeah, it was me.
Sorry, I keep sharing like random shit. So yeah, so the only thing that I really didn't dig, and we brought this up to him. So there's your air water separator, air glycol separator, and there's your external tank. The thing that's wonky is that there is no catch for the actual pop off for the bleed. So the only thing that I'm not really fantastic about is the fact that when that pops off, typically, and some of the other racks that we're accustomed to that the Big W used to do a long time ago, is that you had at least you had a catch for that, and then that's usually where your fill is. There's actually a fill station downstairs. It's that GT1 right there, the glycol fill, and it's something that I've never seen before. And
I love those things.
Do you really?
So we actually had a rack, and it was a Walmart, and this thing would lose like 1.5 gallons of glycol, and it would just shit itself down.
Uh-huh.
And they had a bunch of leaking O-rings on unions. And in
Uh-huh.
order, the mechanical contractor that did it put the union on the wrong side of the ball valve. So
Okay.
in order to shut this thing down, you would have to drain down the whole store. So instead of running a service call out there every other day, we ended up putting one of those in. The autofill. This was everybody's idea. This thing worked flawlessly.
That's horrible, though.
We fixed it when it was planned and able to get done. We had to actually split the store up into sections and do it.
No way.
You talk about draining the entire store down and getting under every single case to change unions.
Whoa, this was every
George
case
Fisher unions. You're huge undertaking. So like it ran for like 6 months and it was perfect. I think we ended up putting like a couple maybe 30 gallons of glycol in them. Like those things work great.
Really?
Yeah, the mechanical buildings, like in Chicago and stuff, you see them everywhere.
Yeah, so you have this feeder that's actually downstairs that's doing all this rigmarole, and like I said, there's no the ball valves or the valves that are in there are like balancing style valves, I believe, when we were going through it, but they don't want you to utilize that. They basically want everything utilized through the VFD. So when you have these things running, it's imperative that you have, because typically there's a bypass fitting at the end. This is the one that they've been using, right? This is really weird. I've never seen one like this. Kevin, maybe you have. You see this thing?
So funny you bring this up, because every single one of the
loops that you have,
every single one of the pump outlets on these smaller pumps have those at this store have those balancing valves with the ball valve on it.
Yeah, and it's weird because it looks like if you're checking the pressure on 1 and 2, it looks like it's this. It is the same, but if you actually that's what I'm saying. If you look down the hole, it doesn't, like this one. Number 1 does actually, you can see daylight through it if you were to pull the Pete's plug off. But number 2, it's basically it's getting it from all the way back here on the other side, which I thought that was neat, because I was like, how do you check the pressure? It's the same thing, you know what I mean? So based off of the pressure difference and based off the size, they're checking this upon startup, but we had an issue where the skid was running fine for a little bit, and then because it had a higher GPM, because it was just barreling through a couple cases, and then they added some cases the next morning, and then everything just went and we were getting, it wasn't even like we were maintaining let's see, trying to maintain, it was a 13-degree saturated. It was supposed to be like 23-degree glycol, and it wasn't pulling down any lower than like 30. So all the cases like randomly just started running warm all of a sudden. So I was going over there anyway to take pictures of some of the CO2 stuff that they're doing, because I'm making a training. So I wanted to take some cool pictures. Didn't get to do that, and ended up having to. This is a proud moment for you, Kev. I was out in the field. So anyway, I was. They didn't have this in there. They actually had an STAD valve. So I was like, oh, I got the fix for that. So I looked it up. I looked what number, and I'm looking at the PNID, and I was like, what size pipe it was, and I was like trying to figure it out. And they had it opened up to, I think, 2.7 or something like that. And when I did the calculation, because they told me at the end of the loop, they had to get it all the way down to 2 GPM, which means it had to be like this big 2-inch line had to be opened like 0.3 or 0.2 or something like that for like bare minimum. And as soon as I did that, because what I was just doing test runs because I didn't know what was going on. I was like, because they have this automatic formula within this Corel controller, which ramps up and ramps down, just try to maintain a certain GPM. And it was maintaining, but as I slowed down the pump, I started getting more thermal conductivity. And then I got to a point where it was too slow and then it started flooding out. So I was like, all right, well, something else is wrong. We're not getting enough flow in. And then we looked at that and I was like, oh, okay, let's close it down. As soon as we closed it down, we started getting the approach that we needed to. I think their approach is either 10 or 6. I'm not sure. I got to look at the schedule. But as soon as we did that, we were getting more, closing down the bypass loop at the end. That started rolling. How do they have yours set on your project that you're working on?
So all these VFD pumps are controlling off of that flow, and they're also the balancing valves are all like 3/4 or halfway cocked. So I haven't quite messed with it because at one point this building was balanced. So I haven't quite messed with it yet.
Mm-hmm.
We're gonna do the fill and flush next week.
The geo loop that you're talking about. So when you're talking about that, because you said there's a domestic hot water loop, right? Which obviously comes off the discharge. There's another water loop that they're using for non-potable water, basically heating water. Is that correct?
Yep. It's a boiler. Yep.
Okay. So they're heating that up to a certain temperature. What the hell is the geo loop doing? What are you trying to do with that?
The geo loop is the condenser in the summertime, and in the wintertime, it's an evaporator. So they're taking water from the ground, it's a ground source heat pump, and they're taking it and mixing it in this chilled water buffer tank.
Okay.
So the geo, the glycol for the geo and the chilled water are the same loop.
Okay.
In a sense. So they're taking the geo water from the wells and dumping it in the chill water buffer tank. Then the chilled water gets chilled by the rack, which makes load for it to heat in the wintertime. It is a giant water source heat pump that also does the refrigeration.
So it actually has reefer lines going out elsewhere.
It has reefer lines also.
To the cases, but it's literally utilizing every bit of heat reclaim known to man.
Yep. It's got 3 forms of heat reclaim, and if it can't ditch it, then it goes back into the gas cooler on the roof. There is so much going on here.
That's amazing.
It's a lot.
Yeah.
This is the first time I've ever gotten a rack that actually ran in a factory before it got shipped out.
Wow.
For 3 weeks.
I guess they wanted to make sure it was working right. So the other weird thing about this rack, which I've seen them before, but I've never really seen them being utilized. This is a dual circuited heat exchanger.
Yeah, all the Costco's are like that.
Yeah, where it has one glycol line going in, one glycol line going out, but then you have two liquid lines and two suction lines coming out of the heat exchanger.
Are they crisscrossed?
No.
So this is for everybody at Costco. So if you look at the dual circuited heat exchangers, so you got say suction line, liquid line, suction line, liquid line. Okay, you look at it, you would think the liquid line's going on the bottom, suction line's coming up the top. It's the opposite.
Is it really? So
the liquid line on the right-hand side is coming out the suction line on the left-hand side. They're crisscross piped. And everybody, there's one little thing on the pump skids from Zero Zone with a little picture on there that the size of a Polaroid that explains this. And like, that is the first thing I do if I see people piping it. I mark them. I go,
wait a minute. What kind of brace exchangers are they?
I don't know.
Because look, so you have circuit 2 liquid, Okay, and then technically this is circuit 2 suctions. Circuit 1.
But yeah, you got to really pay attention because like the ones that Zero Zone uses are cross piped.
That's why I'm looking right now.
So
wouldn't that be
that'll really screw you up when you're piping it. Like you really got to pay attention.
These are piped from the factory, and they use these pretty controllers. You ever use these?
Okay.
They're interesting. They use.
I don't like that you can't adjust the max valve open percentage.
I think you can on those ones. I think.
You got to change. You can, but like you have to manipulate it.
Now you're gonna get me curious about the freaking heat exchanger now.
So the cross piping of the heat exchanger, I've seen so many fitters, like foremen, go to lay out a store and they'll lay it out backwards because it happens all the time.
Really?
But like balancing valves on the outlet of the chillers, 100%. Like I don't care if it has VFD driven pumps and it's going off differential. Mm-hmm. I want to see a balancing valve on the outlet of the chiller because no matter what, especially if you have dual chillers and you're running 2 of them in parallel, without that balancing valve, like you're never going to get the flow right through them, and it affects them. Even if it has the right flow on the system, you're still never going to have equal flow through the chillers without the balancing valves.
So you're talking about running 2 chillers or two heat exchangers in parallel, right?
Yeah, that's how the older Walmarts were, and that's how the Costco's are. They have 2 heat exchangers in parallel.
Today's episode is sponsored by the RefraShield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
Yeah, they do.
Yeah,
but you're right. They have balancing valves on them.
The Walmarts have balancing valves. The Zero Zone design for Costco is no balancing valves, and the older design was a bypass valve around supply to return at the pump station. So they would use differential to bypass supply to return, which is like it somewhat works, but you don't get the efficiency gain from having the VFDs. Like having the VFDs on there, you get way better control of the pump differential. Now, there's all kinds of different ways to do it. You could do it into the line flow, which is technically how you should do it. You should be measuring differential at the end of the line, in the loop, not at the pump skid. But a lot of people are measuring it at the pump skid when the end of the loop is the tried and true measurement, like the hill skids did.
Yes. No, when I did that store where those flexible combiners came from, right? The ones with the lead lag or whatever. That was, they actually they ended up having to drain the whole loop because at one point, so they put it in, and everyone thought someone else was supposed to be doing all that stuff, and then they were like, "No, you're supposed to do it," and I was like, "Where are the taps?" They had to drain the whole glycol system. God, oh yeah, and I don't think they did a refreeze because they actually had to weld the taps. They had to weld the taps in. There was no taps.
Oh, that sucks.
Yeah.
Yeah, it's differential pressure at the end of the loop is the way to do it, and with a true differential pressure switch. Like I see all these people using like transducers. That's not a true differential pressure switch or a sensor. Like an actual differential analog sensor with the 2 lines going into it, and it's giving you the actual differential. It's measuring it in real time. That's what it should be.
Almost like the RDP thing, the Westermeyer. Yes, that.
Yes, that's giving you a true differential in back. The hill ones are a little difficult for people to troubleshoot because they're 4 to 20 milliamps on the transistors coming back. So that throws people off. So it's a 2-wire 4 to 20 milliamp wired signal. But even those ones you could set to run off of your local skid differential too. So what are they looking for a differential on those rays?
It's I don't know. I don't know. There, what was it? I want to say it was like 14, I think. Hold on, let me
15 to 20 seems to be like a solid number of what I've been seeing on like a lot of stuff. Like a 20 degrees pump suction and like a 40 to 45 degree or PSI pump supply.
Yeah, it was shit. I forget what it was when I was there, but basically they're doing 35% propylene glycol. They're saying they're trying to achieve a 3-degree approach,
Which I think is totally doable.
Yes.
There's chiller manufacturers doing that all day long.
Yes. But like I said, so I'm trying to remember what the hell the differential was. I remember, because they're doing a calculation where they're trying to take the feet of head and then basically try to calculate that with the GPM based off of the whatchamacallit, the pump curve. They're basically taking the pump curve to figure out what the GPM is. But when
cool.
What's that?
Which is cool.
Yes, and then so I think they load data from a spreadsheet that they made to basically figure that out. I think they took that from the curve and then just put that in there. But I think when I was there, I think it was probably around 14-pound differential is what it was currently maintaining, and they still hadn't done the startup yet. They were still in the process of adding. I don't know if this was the last set of lineup of cases when I was there, or maybe they had one more lineup to add.
The lower you keep it, and the less you run the pumps, the better. The lower you get the differential, the more energy you're going to save, and the better flow rate you're going to get through the heat exchanger. Everybody thinks more differentials better. Like more differentials worse, especially if you don't need it, because all you're going to do is you're just wasting energy and you're just forcing more glycol through the heat exchanger. If you slow it down, it actually deloads the racks, because if you move glycol too fast through there, it actually loads up the racks.
Too fast or too low?
Too fast. If you force, remember that store where I had you set that circuit setter? It was years ago on the rack, and what it did to the load on the rack.
Yeah, because part of the reason was because it wasn't evaporating all the liquid out. That was where the end bells look like big snowballs.
But then as soon as you did that, it took the load of the rack and just literally flatlined it and went from running all the compressors down to 3.
It was funny because I was in front of not only my guys, but the store's people that were there. And I was like, "Oh, watch this." And I did it with the HY tool and put it to the flow that it was, because I don't know what the hell is with circuit setters. It's almost like the same mentality with expansion valves. Like, just turn it open, just rip it open, and just let it flow. And I remember shutting it down, and everyone that was there gave me the Chris Farley look, like, "What did you do?" And all of a sudden, like you said, it literally went from running all the compressors balls out to the glycol not maintaining temperature, to it plummeting the set point all the way down past what it should have been, came back up, and then if you looked at the graph, it was the first time the thing had floated in the history as far back as it would go.
Yeah. Everybody starts messing with circuit setters, and it ends up messing up a bunch of stuff. So like when I set a circuit setter, I generally lock it with the Allen key in the middle, and then if it needs to get closed down, it can, but you can't open it any farther than that. That generally keeps people from messing with them. Yeah, but especially on the rack, like setting a circuit setter is like key. Like some Pete's port needles. I think everybody should have at least 2 Pete's port needles with the Schrader adapter on there.
100%. Yeah, let me bring up a picture since you're talking about it, because like people should, because they're like, "What the hell are you talking about?" And I just want to bring up a picture. It's like, understand what the hell I'm talking about. Yeah, that whatchamacallit, that what's it? Pete's plug. Pete's plug probe.
It's actually a TMP port. I got corrected today by an engineer.
Pete's?
It's a TNP port.
Oh, okay, but it still came up. It says Pete. All right. So it's like saying a Kleenex. I get it. I get what you're saying, but still.
Yeah.
Do they even have this little cool thing? So you should have had this. Look, it's even for a geothermal loop. Look at that. It looks like someone made that out of their basement.
Oh yeah. What is that thing? $80?
Just send it. Oh, look at that. That's a cheap. Oh, look at that. It's 2 of them for only $36. I got a whole set of them.
Yeah. I have some. I just use my probes. So I got those Pete's port adapters, and I just put a 1/4-inch flare Schrader in there, and that way I could just throw my field piece probes on there. Yeah. And that way I could just look at the differential like that.
Yeah, and so these are on here. These are just covers. They don't do anything. Yeah. They're just
keep
covers.
You from stabbing yourself.
They keep you from stabbing yourself, and just make sure it's fearful the first time you put them in, because you're like, it's not going in. You and the automatic thing is, am I poking this hole through something? Does that mean when I go to pull it out, is it going to go all over the place?
I had one do it. I had one just blow out all over the place, and I'm like trying to force the cat back on. And it's worse when it's glycol. When it's water, nobody really cares. But when it's glycol, it's just ugh.
So back to what you were saying about the whole circuit setter thing, or the glycol fill. I'm against that, because my problem is that I understand your situation, what you're dealing with, but theoretically, like if you have the extra tank in here, because I've seen this happen where an extra tank had let the air out, and then essentially the automatic response of the person that was on site just add glycol, and then I got a call saying that, hey, we have blue stuff coming out of every port in the piping all over the floor. You know what I mean? And it looked like it was low on glycol. And so I went right up to the extra tank when I went there. I was just there training, and they called me on call. They're like, hey, we got glycol all over the place. I don't know what's up. So we went up there. The first thing I did was I took a wrench and knocked on the side of the extra tank, and lo and behold, it was donk, and it was full of glycol. So fortunately, the tank wasn't ruptured. I was able to pressurize it with nitrogen and just push all the remaining glycol that was out there out. Or I'm sorry. Yeah, but the rubber inside was still intact.
Yeah. Yeah, I've had 2 of those fail now like that, and it's just you end up taking out like 20 gallons of extra glycol. But no, the feeder, I see its point. It's nice if you're on a roof and you don't have to force the glycol in. I will say this though, the glycol gets all gooey and nasty in that feeder tank.
Oh, really?
Yeah. Huh. Especially if it's open and it becomes a Band-Aid. It's like having a 100-pound cylinder hooked up to the system.
Here's your feeder tank that you're talking about.
Yeah, so the one we put in was way bigger.
Yeah, this isn't that huge. The other weird thing, and I know we're not going to talk about the CO2 one. I want to wait to get Ray on, but the other one has a battery backup that runs the auxiliary condensing unit for that, which I thought that was wild. You sound like an old man when you do that.
I don't know about battery. But I like batteries, but
I don't know how long it lasts though. That's
yeah, I also like Generac generators.
Yeah, but then you have to run the natural gas and all the others. I get it.
Kind of like there's not natural gas on every single roof.
Not if you're in New York.
Well, who bans appliance like a stove? Like what? No new stoves, only electric.
That is America.
Yeah, exactly. You get them glass top ones that explode.
The what?
Your kid drops one bowl on the a porcelain bowl on the top, and it explodes the whole stove top.
I'm assuming you're talking from experience, sir.
Yes. So yeah, back to the glycol thing. Setting the end of the loops. So that's one thing on this job we have to end up doing. There's no end of the loops, so we have to end up cutting into loop balance valves. So there's no supply to return into the loop. And if you don't have that with a minimum GPM on there, you're going to have a lot of problems. You're going to hit to the point where you're going to be deadheading pumps if things shut off. Jesus.
Is that the guy?
What?
Is that the guy that I know? Because he called me.
No.
Oh.
Like this has been like one of these weeks where it's just like the phone just rings nonstop.
I called the guy today, and he calls me back. He's like, "Hey, this is so and." He's like, "You just called me." I was like, "No, I didn't." He's like, "Yeah, you did." I'm looking at my call log. No, I didn't. And he's going through who he was, and I'm like, "Oh, I did call you." It was one of those days where the phone calls just didn't stop.
Yeah, it was like that all day.
Anyway, so end of loop. There's no end of loop. So the VFDs. So is there a three-way? So there's a three-way valve shutting off the CO2 to the heat exchanger. Is that correct?
There is for what I
don't know.
There's there's a three-way valve that bypasses each heat exchanger. There's a three-way valve that bypasses the geo loop that sends it to the condenser. There's a three-way valve that bypasses the domestic hot water. And then for the chilled water, there's a massive CCM valve driving it. And that's it.
So wouldn't the pump just like cease to stop when it was done?
If it was satisfied and if everything shut off.
Okay.
So everything would have to shut off. Like the geo loop should never shut off. Should always be
because it's constantly warming up that load.
Yep. It's constantly moving. You're constantly need to be charging the field too.
Oh, is this the one?
This is ground source.
No, I know that you said there was one that you worked on where this ground source wasn't big enough.
So that was a different store.
Oh, okay.
Actually, that was my first go around with this. We had a store in semi-southern Illinois, and I went down there because they were having all kinds of problems with the racks, and we were looking at them. It's in IGA. It actually was 100% geothermal IGA. And they ended up having all this geothermal loop stuff. All the racks were water cooled. They were too small. So anytime something wasn't calling for heating, it would overheat the loops.
Interesting.
So the more I learn about geothermal is like, it's like a crapshoot almost, like what they're going to get out of the wells.
Oh, because they don't really know?
They don't really know.
How do you, like, other than, I don't know if that could even be done with like LiDAR? Like something seeing how big the field is?
It seems like it's almost to the point where it's like they guess and overdo it by a certain percentage, and hope and pray for the best that they oversized it? Because how do you know what the actual ground's going to give out? You could do a geological survey, but you don't know what that is going to be in 5 years.
Yeah.
My only problem with the wells is the leak potential.
Oh, that if the well at the bottom leaks, is that what you're saying?
Yeah, if you get a leak in a well, so you can figure out probably what was leaking. You shut it off, but then you lose an entire of capacity.
Yeah.
And it's not like you could fix it.
I was going to come up with some smart ass answer.
There's no fixing it. Like you have to do a new well.
Put some pan seal in there.
Yeah, just circulate some pan seal around, some AC renew.
That's right. What's that shit that they use?
The fucking radiator fix leak.
And put it on the bottom or leak lock. We got leak lock. We could.
Hey, I was in some stores the other day where they were painting leak lock on the outside of components. I swear to God.
Why?
Yeah. The in-house guys.
Do it. Why? Because the shit was leaking?
No, to keep it from leaking. Because receiver gaskets leak a lot, so they were painting the outside of the receiver. I swear to God. And they were like painting CDS valves that had leaked at one point, so they can't leak again. I was like, what in the hell is this?
Oh my God.
Like, I'm talking the biggest jar of Big Blue. I didn't even think they made them that big.
You're talking about the one that's like yay tall,
Yes.
looks like a small coffee can?
The dude was using a paintbrush. I seen that. I put my tool bag right back in my truck. I didn't lean against nothing. I'm like, it's going to get everywhere.
What's worse, leak lock or never sees? Yeah. Marine grade never sees.
Leak lock, because at least the never sees, everything's going to come off. It'll be all over you, but like, at least whatever you're taking apart is going to come apart.
Yeah.
I don't know how many compressors I've destroyed trying to get fittings out of.
Yeah, no, I get angry. I've only used it once in an upright pinch. There was, I forget what the hell it was. I think it was the top of the bellows of A2BL valve that was just copiously just leaking. So I was just doing the Catholic thing, just praying that I would get it to seal, because it was not sealing.
What works good for those? Copeland compressor caps. Some of them, like, they're almost the right threads. With Teflon tape and enough cross threading, it'll seal so you can make it through the night till you get a rebuild kit.
Yeah. So I don't even think you finished answering my question, because we got sidetracked, because it happens. But like you said, you have to set, if there's no, how far is this loop? I obviously know that you have the open loop that goes downstairs to the well, right?
Yep.
But I'm saying the other loops are from the pumps to the heat exchangers. So if those shut off,
and then they go out to the field to air handlers in the store to do the HVAC.
They never shut off then.
So 3 of the air handlers have just straight on-off valves. Okay, they're 4 pipes. Okay, then there's fan coils that have on-off valves. There's 6 fan coils in the store. And then there is 2 air handlers that have throughway valves that are acting as what I assumed was the end of the loop. Technically on those, they were using a throughway valve, so they would always have some flow no matter what, because if those ones weren't on, then it's going to be bypassing. But at the end of those, I have to add balancing valves now. Full size, they want full size loop balancing valves. So it's 1.5 lines, and I have to go turn those into 1.5 balancing valves from supply to return.
So, well, hold on though, because if you're flowing through all the time, I'm like, is this thing going to basically be wide open?
The balancing valve, no. It's going to have a minimum flow GPM through it.
Okay, because I'm thinking almost like a VAV system with static pressure. So if the three-way valve turns where you're not putting it through the heat exchanger, then like you'd have another automated valve that was basically doing the same thing.
Yeah. So basically the way this is going to work is like when there's no heating demand, say like it's Texas and it's 900 degrees in the summer, winter, there's no heating demand. Or summer, there's no heating demand. So those pumps will shut off. If there's no demand and it's not calling for heating, then it's going to shut those pumps off. Then that will be idle. The domestic hot water will always run for the fact that it's got recirc pumps. So it's always going to run. The chilled water will only run on a call for cooling. We'll start the pumps and a call for reheat.
Okay.
So those pumps will turn on and off. The geo pumps should technically run all the time.
Because you're constantly just warming up that loop.
Correct. You either going through the geo heat exchanger or you're going into the geo mixing.
So what does the air conditioning then? So the rack does the air conditioning
off the hot water it's boiling, and then it does it off of the chilled water.
Oh yeah. Oh damn.
So I'm saying, like, there's a lot going on here.
Damn, that is a lot. Oh, I don't know. Is there anything else you want to cover? I know there's tons of we can, but I'm waiting for Ray to get back to me and to talk about all this stuff, because there's ins and outs and stuff. We went to a class, but like I said, I want them on there just in case we have any questions that we could.
The other thing I want to bring up is triple duty valves, because I get a lot of questions about this. What a triple duty valve is. So it is a balancing valve, it is a check valve, and it is a shutoff valve all in one. So you know what I'm talking about, Brett? Like on a bigger pump, you have a triple duty valve on the outlet, which is a check valve.
Oh, it's one of the it looks like a big butterfly valve, but
it could be a butterfly valve. It could have a nub on it.
Balancing valve. It could be, yeah. Okay.
Yeah. So it on the outlet of these pumps, guys, you're gonna see these, especially these bigger pumps, when you start getting like 3, 4, 5 horse, 10 horsepower pumps, you're gonna see on the outlet of these pumps, you're gonna see bolted up to it, you're gonna see a triple duty valve. So it looks like an angular valve, and it's straight in line coming out at a 45-degree angle, like a strainer would be. You're going to have an adjustment on there. So that is going to be your balancing valve for that pump. That is going to set your flow rate through that pump, your GPM. If that is not set properly, you could have a lot of problems. You could have the pump overamping. You could have the flow rates be all messed up. So you want to set it at a certain thing, and you want to be able to lock it in.
Unless they're not utilizing it. If they're using a VFD for the straight pump pressure, that's different.
I mean, you still should have it set for, like, all these balancing guys still claim it still needs to be set for whatever it is, and let the VFD do its thing, but that balancing valve still should be there and be set.
Damn. All right.
Because you still want it for your minimum allowable flow. Now, with these triple duty valves, I always mark them real good, and I mark them with a marker, and then I mark them with a line in there, because you could use that as a shutoff valve. So sometimes they don't have a ball valve on the other side of the pump, and that is your shutoff valve. So you need to crank it in to shut it. Just be gentle, and then that is also your check valve. So if the system were to shut down, and say you were, and what we do, it's not as big of an issue, but let's say you were in like a 10-story high rise, and that shut down, and all that water or glycol is, you have 10 stories of weight. It's going to want to go the opposite way and cause all kinds of issues, blow reliefs, if something like that were to happen. So that's another thing, is to keep in mind, to make sure that valve is set properly and how to utilize it.
I think who makes that? Bell and Glass. Bell and
B&G
Gossett.
triple duty valve. BNG, Bell and Gossett.
That's what I was. Triple duty.
Yeah, their online literature's
Very good.
yeah, 50-50. It's hard to find stuff.
So so I see the one that I think that you're talking about. Blah 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 blah. But I don't know because like I've seen these other ones. I've seen these guys. This is the one that I'm used to seeing. This triple duty one. Is that the one that you're speaking of? Or are you speaking
Sharon. There it goes.
No, I was sharing.
Yeah, I've seen those.
Those ones are the ones that I'm used to seeing.
Yeah, and they also make the one right to the first one. I see those ones a lot too.
Really?
Yeah.
Oh, yeah. Okay. Yeah, I have. Okay.
Where you just put a wrench on the end of it.
Yes.
So that is a triple duty valve, and that is a circuit setter.
That is a big valve.
Oh yeah, we've done a bunch like that.
It's not a cheap valve either. Shit.
No, they're expensive.
Yeah, they is.
Those are going to be setting your minimum. Your VFD is going to be controlling it, but that is there. The VFD fails and you're in bypass. You still need to have that.
So because I don't know. I'm asking because I don't know. Because I don't know as much about hydronics as what I probably should. What would there's a certain amount of flow that the pumps that's supposed to go over the pump?
Correct.
Oh, okay.
And if it does too much, so like the zero zone Costco racks, I learned this from bad experience. What's that?
I remember impeller. Wrong
Yeah.
impeller.
So we had a store, brand new store, and we're doing startup. Every rush, food's coming. We're getting everything in there. We get the glycol in there, or we get the water. We do the first flush, and we had ran it for a little while. We had 2 random overload trips, or whatever. There's a lot going on. Power's hitting shut off, so we reset everything. We drain it down. We start putting the glycol in there, and the piping is shaking. Every time a pump comes on, the supply and return are just walking all over the rack room. Like the hangers are shaking. Something's not right here. I've done enough of these. I'm like, something's wrong. We're going through it, and I'm like, I'm talking to my buddy who does a lot of hydronic stuff, and he's like, sounds like the pump is moving too much.
Mm-hmm.
Like so he had me take a triple duty valve and he made me crank it down. I'm like, it's getting better. It stopped overamping, but I had the triple duty valve almost shut. So I was reducing the flow of a centrifugal pump. I was covering the outlet and reducing the flow.
Yeah.
That ain't right. It's not how it's supposed to be. Turns out like Zero Zone has an 8-inch pump an 8-inch pump. Okay. They grind those impellers down to like 5.5 inches. They didn't do it on that pump, and it still had the 8-inch impeller, which it was moving like an extra like 150 to 200 GPM.
Yeah, wasn't it like triple the amount of flow that it was supposed to originally? I remember that. Because you were. I remember that job. I remember that week. I'm sure
it was hell. Like I was toast. It was like 80 hours in. And it was just like they were taking a pump apart after the manufacturers telling us that we're voiding the warranty, and it's just like, oh, look at that. I'm like, that says 8-inch.
Nice.
Yeah, but so that's why it is incredibly important to set that stuff and make sure your flows are right. And I had to sit there with the pump curve and look at it to figure it out.
Yeah, like I said, I'm working on the head sales guy got back to me today, so hopefully I can get him on here and we can talk about hopefully both their glycol as well as their liquid pump overfeed.
I'm really interested in the glycol side of it. Liquid pump overfeed's simple.
Yeah.
I think the glycol is honestly probably more complicated than the liquid pump overfeed.
And that's what I want them to talk about because like I said, like I'm used to just the pumps maintaining a differential. That's all. But there's There's no circuit setters on any of the any of the heat exchangers, because they're figuring out the GPM based off the differential and the pressure and all that other stuff. And then all the circuit setters on the case are the non-adjustable, which
I like those from a startup perspective. I think they're awesome until you have a case temp issue and you just need a little bit less flow here, a little bit more flow here. Then it's
that's when you start playing with the ball valves.
I'm serious. Like there is stores where we've had to do that at. It's in caps and stuff where the flow is like, or they end up with a haze valve where it's like slightly oversized and it gets down. Now I got to shut this ball valve a little bit. And I usually end up taking the handle off and laying it in the bottom of the case and marking it, because I don't want the store going in there and turning the ball valve off unless they have to, because there's no other way to balance out temps, especially when you get a customer to, once the temps within 1.5 degrees to 2 degrees, they basically give you this unreasonable expectation with no tools to do it.
Yeah, I got you.
Yep. Let's call it.
Yeah, we'll cut it. All right. We'll get, like I said, we're going to get Ray on and talk about their liquid pump overfeed, and we'll delve a little bit more on their pump control, because I don't want to give the sauce away until they get here to give their own sauce away. So I don't know. Until next time, we'll see you guys later.
Another thing we need to get into is, this has been asked, like some more CO2 engineering, because if you look at some of these stores, like I was looking at a store and it's the exact same store over and over again. I'm looking at the loads in the rack. I'm like, this compressor load is like completely different than the next door, but it's the same compressors and on the same setup. I'm like, nah, something's not right here. It's wildly different with some of these ratings.
I was just thinking about, that's a way you could make more money. You could engineer stuff and sell it to the customer. That's something you could do.
Yeah. Everybody can just be an engineer.
Yeah, everybody. It's just easy. You just have to take a expensive class. That's all.
Some engineers are good. Some engineers are not.
I got something to tell you afterwards about somebody that we know, but damn it, I'm mad about it.
Let's wrap it up.
All right. We'll see you guys next time. It's been fun. Later, guys.